Good evening, students. Uh, let's start this session. Let's start this session because it's already 7 and I'm waiting for others to join. So we can start the session now, and in between, if anybody join, we will join them. Okay. So good evening, everyone. Once again, welcome you all to the live session 7 of NPTEL. This NPTEL course is Physics of Renewable Energy Systems and is taught by Professor Amrish Chandra. He is from Department of Physics, IIT Kharagpur. And this live session is taken by me. I'm a research scholar at IIT Bombay. So this session, I planned this session to have a recap where we will have a slide in which we will recap the whole session, and after that we will move to previous old assignment questions and some questions which you can also ask in between from the assignments or any other topic. If you want it needs to be asked or need to be discussed in the live session, we will take up that question, or if there are any minor question in between, you can ask in between also, or if there are big question or you need discussion on some topic, you can ask in the last. Okay, so we start the session now. So here is the revision of previous live session. In previous live session, we actually saw the different types of batteries, different read about different storage systems. Basically, electrochemical storage systems like battery, different types of battery, lithium-ion battery, nickel cadmium battery, and lead acid batteries. How lithium-ion battery works. The main focus was lithium-ion battery because this is the talk of the town. What is talk of the town? When you say talk of the town means this is the hot topic which is going on. And why it is hot? See, I will give you a basic introduction about this. A normal nickel cadmium battery, nickel cadmium lead acid battery, you take. It's basically 40 or 50 watt hour of energy density per kg. But this lithium ion battery are so energy dense, they have energy density of 5 times that of lead acid battery. So size of lead acid battery that you see in your house, like PV lead acid battery, we generally use for our inverter system, we can have 5 times more power when we are using a lithium-ion battery of that size. So that's why these batteries are actually very much important. They are very much on focus right now, and majorly due to the energy density they carry, charging, discharging cycles, all these things are going on. So when you are talking about the electric vehicles, so vehicles are generally associated with range of kilometers. You go to a certain range, 100, 200 kilometer. Okay, someone let's to join. Admin. Okay. So in we were talking about lithium-ion battery, and when we are talking about vehicles, so vehicles are generally associated with a range of kilometer. We go for a good range of kilometers, like 20, 30 kilometers or 200 kilometers. So batteries should be suitable or commercially available, so that if we are going for 30 kilometers or 300 kilometers, the batteries should be stable. It should store the charge so that we can go to that kilometer. It can be charged very fastly. So all these properties, capabilities are actually present in this lithium-ion battery. So that's why these lithium-ion batteries are most of the focus now. And one more thing is we need to study the constituents or the composition, or how the lithium-ion batteries are actually made from inside. So lithium-ion batteries are similarly like any electrochemical battery. These are not different. You have two electrodes. One is anode and another one is cathode. And Basically, these electrodes are made up of graphene layers, and also lithium chloride oxide, something LiClO4 something. So these are some of the compounds of lithium which we use to make electrodes for this battery. And there is electrolyte in between these two electrodes and a separator membrane in between two electrodes. So why there is a separator membrane? Separator membrane is typically installed to avoid the short circuit between these two electrodes actually. So if there are two electrodes, let me show you. If this is electrode and this is electrode, so there will be a separator membrane in between two, which will actually prevent the short circuit of these two electrodes. Okay, because ions are flowing in between. So remember, the current flows through the outer circuit, the ion flows through the electrolyte. So there is electrolyte, the ions flow through it. And also what happens, this separator membrane, what it does, it actually selectively gives permission to pass the ions only. Okay, so if there are impurities, they will be trapped at one side or something, and some other ions or molecules cannot be passed. Only the ions associated with the electrolyte or electrode will pass. So that's how this separator membrane is designed. Or this have a very small thickness, very small thickness. So you will, I think, less than 1 mm or 0.1 mm. So you will have to actually, you are seeing a large image here. You can check the thickness values in the slides also. Sir has actually given it in the slides. So this is actually a total lithium ion battery. Okay, so now it is clear. The lithium ion battery is basically an electrode made of lithium metal oxides. Then there is a lithium metal carbon. This is basically graphene. Okay, some lithium ions are actually embedded in it, or maybe not. Generally, it's graphene. Another thing which we discussed about the stacking of batteries. So like we have coin cell, you have seen some small cells behind your wristwatches, so that's our coin stack cell, actually called coin cells. We have pow cells, prismatic cells, similar other cells also, depending on how these cells are actually arranged, how electrodes are arranged, electrolyte are arranged. And generally the small pencil battery, the electrolytes were earlier, or for lead acid it's dilute sulfuric acid, acidic electrolyte, but generally for compact cells we are using alkaline electrolyte. Okay, so this is the main difference between these two type of batteries. And another thing is that batteries, electrochemical batteries, they generally work on the concept of redox reaction. And redox reaction is basically reduction oxidation reaction. So reduction oxidation reaction is what? A chemical reaction in which electrons are basically transferred from one electrode, then it reacts with another, then this whole process goes on repeating. Okay, so that's how a redox reaction takes place till the time equilibrium is reached. And this electrode, we were talking about the lithium ion battery. So what is it? This is actually oxide of lithium. So this is the major electrode which we use in lithium ion battery. Another thing we discussed about the open circuit voltage. So what is the open circuit voltage? Open circuit voltage is basically voltage between two electrodes when the loads are removed. Okay, open circuit is open, we don't have any load. So what should be the voltage between these two connecting wires? We measure it and we term it as open circuit voltage. So why this is important? This open circuit voltage actually measures without any load how much voltage you are getting actually. So when you connect a load between, the current will flow. Open circuit, a short circuit current is actually measured. See, this open circuit and short circuit, open circuit voltage and short circuit current are basically very much used. These concepts are very much used in testing of solar cells. So they test the open circuit voltage, short circuit current, these things, and describe the performance characteristics of the solar cell. Okay. So that's where they are also used in the battery. Whenever there will be a solar cell is also like a kind of battery. So we have two p-n junction diodes. They are separated through depletion region. Then holes, electron pairs are actually depleted. Then are formed. These electrons pass through the outer load, and that's how the load is ignited. If the load is bulb, it will be ignited, or if the load is electric resistance heater, it will be heated. Okay, so that's how this thing actually works. And the third concept we discussed, we actually done a numerical based on this. So I thought this was important, so let's actually practice it once again. So actually what happens in battery, how much the voltage you will get is basically dependent on the Gibbs free energy of the battery. So Gibbs free energy is given by N into F into E. What is N? So N is number of moles of electron transferred, okay, the electrolyte or something, anything. And F is a Faraday's constant. This is a Faraday's constant, generally equals to 96500. It's 96400 to be exact. And E is the cell potential. Okay, that's how you multiply it, you get the Gibbs energy. So if there is a Gibbs energy given, they are saying, asking how many number of moles of electron transferred. So you can calculate it, putting the value there, or if they give 5 moles of electron actually transferred, so you can calculate the cell potential also. Also, make sure you actually understand the concept here. Okay. And the main concept here is, if there is 10 electrons, moles of electron in the electrolyte solution or the battery or something, anything. So only of these 10, 5 are actually transferred. So how much should be the value of n? This is important. So these are actually important concepts here. So n will always be equal to the number of moles of electron that is transferred in between these two sources. Okay, it will not be equal to 10. It will be always equal to 5. Okay. So I think the revision of the previous live session is over, and we will be actually, we have discussed about lithium battery, we discussed about the open circuit voltage, the chemical reaction, redox reaction gives me energy, all these things, all these type of things. So if there are any questions, any question related to these concepts, you are always free to ask them on that discussion forum of the course page. I actually go and read all these questions. So what is the main purpose of having a discussion forum is that when you ask question on discussion forum, all of the students who are registered for this course gets benefited. So that's why discussion forum is actually important. Okay. So we move to the live session 7. The first question is, what disadvantage of Goe-Chapman model is? So, if we see the question, we first have to see what are the concepts involved in the question. This question is basically a theoretical question. You don't have to apply so much of mind. You just, if you know the answer, you can tick it. Okay. But the main thing is not answer. Main thing is why. What is the concept that is involved in it? Okay. So the concept is basically Goe-Chapman model. What is Goe-Chapman model? Goe-Chapman model actually describes a rigid charge surface, and what it says, if somebody wants to join. Okay, so we were actually discussing here what is the disadvantage of Goe-Chapman model. Basically, this question is only theoretical question. You don't have to apply so much of mind. You just if you know the answer, you can take the answer. But the main thing is not answer. You need to understand the concept behind this question. So what is the concept involved here? The concept is Goe-Chapman model. Okay. So we will understand what this actually means. What is this model? So this model is very much important if you see actually for supercapacitors, pseudocapacitors, all these things. So what happens actually, these are actually, this model actually describes a rigid charge surface. You know, charge surface rigid, you know, that cannot be bended or something. With a cloud of oppositely charged ions in the solution, the concentration of the oppositely charged ion decrease with the distance from the surface. Okay. So what happens? What this model is actually saying? if there is a solution and seems this is the surface. Okay, so if there is a solution and in this solution there are some oppositely charged particles, charged ions, so that oppositely charged ions will actually, what happens, oppositely charged ions actually attract each other. So if there is negative negative here, this will get attracted. So this is a simple concept which he describes through his model. Like all of the ions will be moved towards this plate because oppositely charged actually. So as you move through this distance, move in this direction, you will find lesser and lesser ions actually of oppositely charged. Okay, why? Because there is a force of attraction that attracts. So this model actually describes this concept here. So for Gay-Chapman model, what is the disadvantage? Basically, disadvantage of Gay-Chapman model is it actually assumes a point charge, a single point charge it assumes. So this is a major disadvantage. Second is assumption of fixed layer of oppositely charged ions in solution. So what it says, a fixed layer of it is not fixed. It is actually in the solution. So if there are ions in the solution, it will be moving. And overestimation of ionic concentration close to the charged surface. Yeah, because if this is the charged surface, so there will be some ionic concentration or more ionic concentration. But this Gay-Chapman model actually overestimate this ionic concentration. So that has to be actually focused, because this when we apply this Gay-Chapman model, it actually says that all the ions will be very much near to the oppositely charged ions will be very much near to this surface only. So that's why it is important. Okay, Gay-Chapman model. So you got the answer. Answer is A and the answer is C. So we reject D and we reject D here. Okay. Now we move to the next question. So the next question is for EDLCs, the cyclic voltammetry curve should be nearly. So EDLC are electric double layer charge supercapacitors. Okay, so EDLC are actually this plus charge, this is plus charge, this is minus charge. So what it forms a double layer of charge. So that's why EDLC is capacitors with double layer of charge. Okay. So these are capacitor plates, then there will be a double layer of charge here. And in between this is the electrolyte, dielectric. In supercapacitors generally it is electrolyte. Okay. For capacitor it is dielectric. So what does it say? The EDLC, the cyclic voltammetry curve should be nearly. So we need to understand the cyclic voltammetry curve. What is cyclic voltammetry curve? Cyclic voltammetry curve is basically charging discharging curve we actually observe in case of capacitors. So what happens when you observe the cyclic voltammetry curve of any EDLC? It will be like this only. It will make say go for charging, then discharging, then the same also charging, discharging, here charging, discharging. It actually makes a rectangular shape. Okay, you can see not a perfect rectangular, but it is a rectangular like here you can see. Rectangular. It is not linear. Why not linear? What is a linear? Linear is something which is a function of x and varies with x. Okay, so if x equal to y, so if we increase y, there will be a certainly increase in x. So if we increase y into 1, multiply y by 1, similarly x will be multiplied by 1. So this is called linear increase. So they will form a straight line on the curve. If you plot x and y, it will form a straight line. And what is non-linear? Non-linear are actually powers. So if you put a power here or multiply something by x, y, so it will actually, it doesn't increase in power of y doesn't mean similar increase in x. So that's why it is called non-linear. It will be generally a curve. Okay. Rectangular are basically charging discharging cycle. Quasi-triangulars are generally out like this. So here what we observe a rectangular cyclic voltammetric curve. So that's why that is the concept we need to keep in mind. So if there in exams, someone ask someone or in NPTEL exam, final exam, if there is a question for ADSC, the voltammetric curve should be nearly like, they have also written the word nearly. Nearly is approximately thing that looks like this, but not actually this. Okay. So it looks like a rectangle, but it is not a rectangle. So the correct answer is, want to join? Let me. So we discussed here the cyclic voltammetry curve. What it should be? It should be a rectangle. I put, actually that's why I put the figures here. So if I say cyclic voltammetry curves are rectangle, so you guys will listen and then forward. So that's why it is very important to visualize these things. How this cyclic voltammetry curve? What is cyclic voltammetry curve? So these things are important. What are electrically double layer charge capacitors? Okay. So you need to know about these concepts actually. Now we move to the next question. Next question is, the Coulombic efficiency can be expressed as. So it's Coulombic efficiency. Coulombic efficiency comes from word Coulomb. If you don't know the answer, if there are no options, you just have to guess. Or if someone asks you a question, it doesn't give you any options or any multiple choice. So just you want to guess. First, you need to understand the question. Actually, what does question ask? Don't hurry. Just give a time to question. What does it ask? You know the answer. It's okay. No more. No. Why? What is Coulombic efficiency? How it can be varied? Can the Coulombic efficiency be applied to anything, or it is very much related with charging discharging only? So you need to understand these concepts. Okay. So if we see the Coulombic efficiency, the Coulombic efficiency basically comes from word Coulomb, and Coulomb is actually associated with, he was a very great scientist. So when you actually talk about some scientists, you should have respect for Coulomb. So, uh, when Coulomb, Mr. Coulomb actually basically work on the concept of charge. Okay, so you know that something will be related to charge. Coulombic efficiency will be related to charge. So let's see what it is related to. The Coulombic efficiency is usually used to describe the released battery capacity. It refers to the ratio of discharge capacity after the full charge and the charging capacity of the sensor. Okay. So it basically describes the battery capacity or the function of battery, how it charges, discharges, or something. So what it is, Coulombic efficiency? It is a ratio of discharge capacity after the full charge. When you full charge a capacitor, uh, generally after the full charging, when you take the charge out, it will discharge after some time. Okay, so after discharging, then again the full charging. So what is cycle? When you charge to 100%, then you discharge to 0%. Okay, this constitutes a cycle. So you know what is Coulombic efficiency? Coulombic efficiency ratio of discharge capacity after the full charge and the charging capacity of the same cycle. So first option is charging upon discharge. So this cannot be. Second option is discharge upon charging time. So this is the right option. Third is, they just confuse you with giving the option. You just have to understand the concept and learn the concept. That's all. Any question, any multiple choices, you will always take it. So charging by discharge time whole square is not a whole square. It is just a ratio. So and the square root of discharging or charging time. This is also correct. So the correct answer is B. Okay. Now the fourth question. The fourth question actually asks about the cyclic stability of battery EDLC pseudocapacitor can be specified. So you just need to know the cyclic stability of in the order. You know the cyclic stability of battery, EDLC or pseudocapacitor. You can easily mark this question. So we will not go into that. We will go into detail. So what are these first? So pseudocapacitor is actually pseudo. What is pseudo? Pseudo is something that behaves like capacitor. Okay. Pseudocapacitor actually stores electrical energy faradically with charge for electron charge transfer between electrode and electrolyte. So pseudocapacitor is something like capacitor that stores the charge for transfer between electrode and electrolyte. What is a battery? You know battery basically stores energy in the form of chemical energy, and whenever there is a demand it actually releases, there is a reaction going on, redox reaction, and it releases electrical energy. And electric double layer capacitance we discussed some 2-3 slides earlier. So electric double layer capacitance actually can store energy by ion absorption. Basically electric double layer capacitance, you have a double layer of charge at each electrode. This is the electrode in between permeable. So this is how it is, electric double layer charge capacitance. And it can store energy in ionic absorption, okay, and whereas pseudocapacitor stores energy by surface reduction. So this is the main difference between EDLC and pseudocapacitor. Pseudocapacitor actually stores energy by surface reduction, where the reaction are occurring at the surface. But in electric double layer capacitance, the energy is stored by ionic absorption. Okay. So you learn the concept of battery, EDLC, supercapacitors, Helmholtz double layer supercapacitor. There are a hell lot of things. Basically, supercapacitors are top of the town. Top of the town, yeah, top of the town because supercapacitors are actually a lot of research are going on. So when I was there in some lab, some PhD lab, so they were, there is a problem of stubble burning in North India, generally in the region of Punjab, Haryana, Western UP, Delhi. So Delhi had to suffer a lot because of uh, this stubble burning thing, because the air gets polluted. There is a low pressure zone created there that sucks up all the polluted air there. Very hell lot of different to live at that time in Delhi. So Delhi is just like pollution, uh, polluted city, most polluted city in the world. And it's a capital city, so government have to actually look after that and to think about innovative ways how they can handle this stubble burning, how they can be paid, the farmers can be paid so that they can sell the stubble to the commercial companies or government, but don't burn it. So there was a research going on in which actually that stubble is basically the leftover residue of wheat or rice or something. So what they do, they actually burn to prepare the fields very fast. So they have to sow for next crop. So they don't take the stubble out; they just burn it down. And due to that burning, a hell lot of pollution, lot of environmental emissions. So if we go for life cycle assessment of this stubble burning, it will have a very impact on them. We'll see a lot of impact on environment, on different subsystem components of the environment. Okay. So what he has done, he has actually converted it nanoform and converted the stubble to activated carbon physics lab. And then activated carbon will actually think of being used as electrode or prepare supercapacitor. That's how innovative is a supercapacitor can be linked to stubble burning as general public problem. We read a lot of things. We read ADLC, we read battery, we read capacitors, supercapacitors, Helmholtz double layer capacitors, a lot of things. You just have to apply simple concepts to solve the general public or social issue. Okay, that's why these things are very much important to learn. You can apply if you are actually more, what to say, more skillful into it. You can go for opening a company. You can sell your products also. Like if he has made this supercapacitor from that parali, that double. So similarly, if that supercapacitor works better, it has a better efficiency, better effectiveness, and the market available supercapacitor, he can sell it, or he can sell the technology, or can get the money, or can earn royalty on it also, or he can put his own company and then start selling that supercapacitor. He will actually solve the problem also. He will earn the profit also. So that's how actually that is why a lot of promotion is needed for startup ventures. Okay. The startups are companies that mainly working on the latest technology. So that's why you need to look for the startups. You need to understand how they work. What are the technologies that they are using? Okay. Now moving over to the next question. So the next question is in electric double layer. Okay, I didn't answer the previous question. So previous question, the answer is correct answer is D. So A. Okay. So what is the? It's actually battery. Motorcycle stability less. Next is supercapacitor. Is electric double layer. So the correct answer is question 5. The question 5 says in EDLC, the separation between the two layer is generally of the order of. So in EDLC, you have two electrodes, that is two layers, uh, charge layers. Right? So they are very located very small distance. You just have to know the distance. It's basically in the nanometers. Yeah. Their charge are actually stored in very compact spaces. So they are actually stored in nanometers. So the correct answer is nanometer. Okay, and actually I put millimeter, micrometer, 10 to the power minus millimeter, millimeter, 10 to the power minus 6 is meter, nanometer is 10 to the power minus. How much is femtometer? So just you can imagine femtometer are even smaller than nanometer. So the actual femtometer is 10 to the power minus 15. Where the distances are measured in femtometer. So in nucleus of any atom, the protons and neutrons are actually situated. So in between these protons and neutrons or the other particles and nucleus, the distances are generally present in the form of femtometer. Okay. And there is a very famous quote also. So I was talking about nanometer and smaller distances, so I thought that a quote will be perfect. This is the quote by Richard Feynman, and he actually delivered it in 1902 or something, university speech or some society speech about it. And a beautiful line is there that there is plenty of room at the bottom. So we see that when uh, any stone or ball or something. So you see that it is very compact, it cannot be compressible or nothing, there are no spaces left in between them. But when you go down and down and down, you will see that oh, there is lots of spaces available there. So in I think 2-3 live session earlier, we actually first or second live session we actually discussed about the primitive cells, body center, face center. So you're seeing that in that just the atoms are actually situated on the corners or on the body, and most of the spaces are empty. That spaces are called void, empty spaces. Electrons actually move in between these voids. Okay. So there is plenty of room at the bottom by Richard Feynman, very renowned scientist, Richard Feynman. I think he has some work on nanometer also. Moving over to the next question. We have to discuss your questions here. So, which of the following is organic redox additive? First thing you have to look is redox. So, redox is reduction oxidation, a chemical reaction involving transfer of electrons. Second is additive. Additive is something which is added. and another thing is organic. So first look at the option. The first option is potassium ferrocyanide. And does it seem organic? Potassium? Potassium is inorganic. Okay. It doesn't have any carbon origin. So it is inorganic. So it is not the correct answer. Vanadium sulfate. Vanadium vanadium. Okay, vanadium from vanadium. This doesn't have any carbon origin. Third is potassium hydroxide. This cannot be because potassium doesn't have any carbon origin or electro origin. And the fourth is hydroquinone. So hydroquinone, yeah, have some carbon atoms and all these things. So this is the basically organic redox additive. Okay, the correct answer is answer C. So you just, if you don't know the answer also, you can just look at the answer. You can observe what is there, and you can take mark to the correct answer. Okay. So that's how that is to be kept in mind. Ki how you actually select answer even if you don't know. Seventh question is for redox pseudocapacitor, the experimentally measurable capacitance is proportional to not the redox potential, it is the Faraday's constant. So if here is Faraday's constant is redox constant. So, this is a pure theoretical question. This has been derived in the slides also. I think you can go and see even in the slides. The correct answer is answer D. Okay, so this is actually for redox supercapacitor that geometry measurable capacitance is proportional to this is the point. Among the various electrolytes used for supercapacitor application, the largest potential window can be achieved for. This is also a simple question. You just have to know the answer. So the correct answer is ionic electrolyte. Generally ionic electrolytes are ions electrons, so that's why they are used the largest potential window or the redox electrolyte. I haven't heard of. Maybe uh, acidic aqueous in much better than first. And if it is neutral, then there will be less or directly balanced. The correct answer is C. So that's how today's session has actually ended. Uh, we discussed about the previous sessions. We discussed the lithium and battery, the concepts, and open circuit voltage, waste free energy. We discussed the Chapman model and saw how it is actually that, what are the disadvantages. Then we discussed the cyclic voltammetry curve, and for ADLC we actually showed that it is a rectangle. We saw the Coulombic efficiency term and actually defined it. It is actually ratio of the charge capacity after the full charge and the charging capacity of the. Next is cyclic stability. So we saw that the cyclic stability of ADLC are much higher than pseudocapacitor and higher than battery. In ADLC, the separation of between two layers actually charge layer are nano. Organic redox additive is hydroquinone. The correct proportional to is B. For option A, it is ionic. Okay, that's how this session today ends. So if there are any queries, I suggest you all to write it in discussion forum. We can have a discussion also. If there are any questions related to today's lecture, today's live session, please feel free to ask any questions and have discussion also. Your time, students. Welcome. So if there are any queries related to today's live session, you please feel free to ask any questions or any question related to lecture or previous discussed concepts, slides, questions, anything. Okay. If there are no queries, can end this session.